Thank you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of December 2023. This question is from the section Real Analysis and it is related to the basic ideas of real analysis. This question is placed in part B, which is a multiple choice question. It carries 3 marks. The question ID is 704041. This question is suitable for all these examinations. Right. The given question is, let f be a function from the set of real numbers to itself, defined by f of x is equal to 1 minus x whole square into sine x square when x belongs to the open interval 0 to 1 and f of x is equal to 0 otherwise, and f prime be its derivative. Let S be the set of all those real numbers C satisfying f prime x less than or equal to C times f of x for all x belongs to R. Which of the following is true? We are given 4 options. Option 1, S is an empty set. Option 2, S is not empty and S is a proper subset of the open interval 1 to infinity. Option 3, the open interval 2 comma infinity is a proper subset of S. Option 4, S is the intersection. Yes, its intersection with the open interval 0 to 1 is not empty. And in this, if you show the option 1, that is S is equal to 5, then all the remaining will be false. You can verify that very easily and quickly. Right. We will now discuss the solution of the problem in detail. We have a function f from R to R defined by f of x is equal to 1 minus x whole square sine x square when x belongs to the open interval 0 to 1. Is the f of x is equal to 0 otherwise. Given S is the set of all those real numbers C satisfying f prime x less than or equal to C times f of x for all x belongs to R. Now, assume that there exists a C belongs to R such that f prime x minus C times f of x is less than or equal to 0 for all x belongs to R. Agreed. Agreed. Now, we multiply throughout by e power minus Cx. And that will imply e power minus Cx multiplied by f prime x minus C times f of x is less than or equal to 0 for all x belongs to R. Now, note down, f prime x minus C times f of x is not a perfect differential. But if you multiply by the integrating factor e to the power of minus Cx, then after multiplication, e to the power of minus x into, in brackets, f prime x minus C times f of x will become perfect differential. For that reason, we have multiplied throughout by e to the power of minus Cx, and by multiplying by e to the power of minus cx, the inequality will not be disturbed because e to the power of minus cx for all values of c, for all values of x, it is positive. Agreed. Now this becomes perfect differential. Then d by dx of e to the power of minus cx into f of x, which is less than or equal to 0 for all x belongs to R. Now this says something like a function g of x, its derivative, that means g prime x less than or equal to 0 for all x belongs to R, means gx is a decreasing function. So e to the power of minus cx into f of x is a decreasing function on R. When it is a decreasing function on R, it's also a decreasing function on the open interval 0 to 1. Agreed. Now x belongs to 0 to 1, that means 0 less than x less than 1, that means x greater than 0. So now x greater than 0 will give you e to the power of minus x into fx, that is the function, is less than or equal to e to the power of minus x into f of x, its value at x is equal to 0. Right? X greater than 0, this is less than or equal because it is decreasing. And why it is so? Because e to the power of minus x into f of x is a decreasing function. Right. And what is the value here? F of x, when x is equal to 0, f of 0, go back to the definition of f of x. It is x belongs to the open interval 0 to 1, therefore x is equal to 0 will lie in otherwise. So the f of 0 is 0. So this is e to the power of minus x into f of x less than or equal to 0 because f of 0 is 0. Right. So this will imply f of x less than or equal to 0. Why? Because e to the power of minus cx is always positive. Is always positive for all values of c. So therefore, even if you divide by that, that means as if that you are multiplying by a positive quantity, it is less than or equal to 0. So thus, f of x is less than or equal to 0 on the open interval 0 to 1. This is the conclusion what we have got by this discussion. Note that f of x is greater than 0 for all x belongs to 0 to 1. So go back to the definition. X belongs to 0 to 1. That f of x is 1 minus x whole square into sine x square. When x lies between 0 and 1, 1 minus x whole square is positive. Sine of x square is positive. Sine of x square is positive. That is why f of x is positive in the open interval 0 to 1. Because 1 minus x whole square greater than 0, sine x square greater than 0 for all x belongs to 0 to 1. Now we got two conclusions. One is f of x less than or equal to 0 for all on 0 to 1, open interval 0 to 1. The other one is f of x is greater than 0 for all x belongs to 0 to 1. 0 to 1. This is a fact. This greater than 0 for all x belongs to 0 to 1 is a fact because it is coming from the definition. Given function. But whereas f of x less than or equal to 0 on 0 to 1 is the conclusion that we have drawn that there exists a c belongs to R such that f prime x minus c times f of x less than or equal to 0 for all x belongs to R. Right. These two things put together, f of x less than or equal to 0 for on 0 to 1, open interval 0 to 1, f of x greater than 0 for all x belongs to 0 to 1 will give you a contradiction. So thus we arrive at a contradiction. This contradiction is because of the assumption that there exists a c satisfying this one. So from this contradiction we conclude that there does not exist a c belongs to R such that f prime x minus c times f of x less than or equal to 0 for all x belongs to R. That means the set S is the set of all those real numbers c such that f prime x less than or equal to c times f of x for all x belongs to R. So that means there does not exist a c belongs to R satisfying this. That means S is empty. S is an empty set. Now look back our options. So S is empty stands against option 1. Therefore, option 1 is true. Now, when S is empty, so S is not empty, S is contained in 1 to infinity is not possible. And option 2 is not possible. Option 3, 2 comma infinity is contained in S is not possible because S is empty. And when S is empty, S intersection open interval 0 to 1 is empty, intersection open interval 0 to 1 is empty, but it is given not empty. Therefore, option 4 is also not true. So the options 2, 3, 4 are not true. Combining, summarizing all the options, we get the answer to this question is option 1. And that is the detailed discussion of the solution of this problem from the section real analysis, which is based on the basic ideas of real analysis. And this question, in my opinion, it is very, very, very easy. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.